In this video, we're going to talk about complex root of a polynomial or complex zero of a polynomial. Okay, so complex number is of this type, like a plus bi. So if this is a root or zero of a polynomial, then its conjugate, that is the sign changed of the I term, then its conjugate is also the root of the same polynomial. Meaning that if a complex number is the polynomial, its conjugate is also the root of that polynomial. Okay, so the complex root always come in pair. They do not come alone. They always come in a pair. Okay, so let's see this example. Find the remaining roots of a polynomial equation of degree 5 whose three roots are 1, 3 minus I, and 5i. Okay, so three roots are given, but it is degree 5, so there are remaining two roots left. Okay, so what are those remaining two roots? Since 3 minus 1 is the root, then the other remaining roots are, one must be 3 plus I, because 3 minus I is a root, and the complex root always come in a pair, meaning that if a complex number is a root, then its conjugate must be the root of that polynomial again. And the other root must be negative 5i, because the complex conjugate of 5i is negative 5i. So these are the roots, remaining roots of this polynomial. Okay, now, so we want to find all the roots of this polynomial, maybe complex root or real roots, both. So you want to find the all roots of this polynomial. The first thing you do is you list the potential root. So first of all, you find out solution. Okay, find out P. P is the factors of the constant term, negative 8. So what are the factors of negative 8? Plus minus 1, plus minus 2, plus minus 4, and plus minus 8. So these are the factors of negative 8. Now Q is the factor of the leading coefficient, that is 1 here. So factors of 1, that is plus minus 1. So what is P over Q? That is the ratio of P and Q. So this will give you the potential roots. That will be this divided, that is plus minus 1, plus minus 2, plus minus 4, and plus minus 8. Okay, now draw the graph of this function. In the graph, enter this thing in y1 equals to. If you enter that, then you got this graph. So from the graph you can see that it looks like negative 1 is a root and 2 is a root, but you want to make sure by doing second trace and then enter. If you enter x equals to negative 1, you will get y equals to 0. So from the graph, the real roots are x equals to negative 1 and then x equals to 2. When you do the second trace and then enter x equals to 2, you get y equals to 0, meaning the remainder is 0 there again. So x equals to negative 1 and x equals to 2 are the roots. Now we want to find the remaining roots. How many roots are remaining? Since the degree is 4, there must be 4 roots in total, real or imaginary. Okay, but we got the 2 real roots, so we need 2 imaginary roots left. So how do I find those imaginary roots? We do the synthetic division again. Now, so we know that x equals to negative 1 and 2 are the roots. What we do is, let's start with negative 1 and so let me write the coefficients and let me set up for the synthetic division. So x to the 4th, x to the cubed, x squared, x, and then constant. So constant, right? So after you do this, what do you get? So what is the coefficient of x to the 4th? 1, negative 1, 2, negative 4, and the constant is negative 8. Let us complete with negative 1. Let us complete these numbers, this synthetic division for x equals to negative 1. And what do you get? So we pick this first, right? So what do you get? 1 goes to 1 directly. So negative 1 times 1 is negative 1. So you add all those all the time, right? So negative 1 will be negative 2. Okay, so negative 1 times negative 2 is positive 2. So 2 plus 2 is 4. Now negative 1 times 4 is negative 4. Okay, so negative 4 is negative 8. Again, negative 1 times negative 1 is positive 8. So negative 8 plus 8 will be 0. So the remainder is 0, right? So what is the quotient? So this will be x cubed minus 2x cubed, x cubed minus 2x squared plus 4x minus 8, because you decrease 1. But you don't have to find that, because you know that x equals to 2 is another root. So you can continue the same table by writing 2 there, okay? Because we know that 2 is also the root. So you write 2 there, okay? Now do the same thing. You do that, and then there will be dotted line there, okay? Now, so 1 goes 1 directly. So 2 times 1 is 2. Okay, negative 2 plus 2 will be 0, and 2 times 0 is 0. 4 plus 0 is 4. 2 times 4 is 8. Negative 8 plus 8 is 0. Okay, so we did the synthetic division twice because we knew that x equals to negative 1 and x equals to 2, both are the roots. So we did for negative 1 synthetic division, we got this, and continue that same table, and then we start with 2. We did with 2, so we got that. So can you tell me what is the quotient? So the quotient is this is x4, this will be x to the third, this will be x squared, right? So it will be x squared plus 0 times x plus 4, right? So what do you get? In fact, this is basically x squared plus 4. Now to find out the remaining root, you solve this quotient. So if you solve x squared plus 4, what do you get? So let's do that. So here, so you got x squared plus 4, you solve it, set that equals to 0, subtract 4, what do you get? You got x squared equals to negative 4. Now take the square root, right? When you take the square root, you should consider both plus and minus. You got x equals to plus minus square root of negative 4. So what is square root of negative 4? That is, you're right, that is plus minus 2i. Plus minus 2i. So what are the roots then? What is the final answer then? So the total roots are x equals to negative 1, 2, and then 2i, negative 1, 2, and then 2i, and then minus 2i. So there are 4 roots, right? This is degree 4, so there will be 4 roots, and we found all those 4 roots: negative 1, 2, 2i, and negative 2i. Okay, thank you guys.